Hi, I will make a simple test of high temperature filaments with boiling water. Yes, boiling water, this is about 100 degrees of Celsius. Actually, when I will put water, boiling water in these cans, it will be not 100 but about 95, something about it. Yes, this is a simple test, but this simple test can tell us some important information if these high temperature filaments really works. Because I know some high temperature filaments from previous years. This materials was declared with 100 degrees of Celsius resistance, temperature resistance, but it was not true. Yes. This temperature resistance was actually more about 70, 80 degrees of Celsius, but 100, no way. Yes. When I make a similar can from old filaments, high temperature, and put hot water inside, it was just changing the shape of can. Yes, it was soft. So, but now we have a new high temperature filaments, and I want just try how it will works. I have standard PLA, HPLA, HD-PLA and new Z-UltraT PLA. I will make some descriptions of these materials later, one by one. So I print these cans on one perimeter in vase mode, yes, and I hope we will see which filament is okay and which not. Because these filaments are not very expensive. Price is almost same like standard PLA, or maybe 100% plus, but not 1000% plus of price. Because we have some really special filaments with 10 times higher price, with really strong temperature resistance, about 250 degrees of Celsius. But for this really nice and really resistance filaments, you need, for example, hot end with printing temperature 350 degrees of Celsius, and hot bed with temperature, for example, 130 or 150 and degrees of Celsius. And for bigger parts you need a temperature beside of printed part, for example 100 degrees of Celsius. So nothing normal, nothing for normal printers, yes, but these materials are absolutely normal about technology of 3D print, about settings, etc. with some comments about. And now I will tell you something about these materials one by one. First filament will be ordinary PLA, cheap Polish ordinary PLA with resistance about 50 or 60 degrees of Celsius. Unfortunately, this sample probably will finish with big deformation. Yes, this will be bad, probably. Next material will be much better. This is HD-PLA by Polish company Fibrology HD-PLA, and with annealing procedure, temperature resistance is about 140 degrees of Celsius. Annealing, what does it mean? You will just print your part. During print, this is just standard PLA, no problem during print. Hot end temperature, hotbed temperature, everything is just same like normal PLA without any problems. And after print, best solution is directly on a mirror or on glass. If you use this on a hotbed, you will put with supports and everything. If you have supports, you will put it in oven, and you will anneal it in oven for 15 minutes for 80 degrees of Celsius. This temperature must be exact, I don't know, for maybe 5 degrees minus or 5 degrees plus. Because if you will use lower temperature, you will not have higher temperature resistance, and if you will use higher temperature, 90-95, your printed parts will be deformed. Yes, like standard PLA in high temperature. So you must be sure with right temperature in your oven, and I use normal time is about 15 minutes, but I use longer times, and I use about 20-25 minutes for 70. After that, next 20 minutes for 85 or 90, and after next half hour maybe 100 on 110. If you will increase temperature continuously, you will have really strong and high temperature resistant part. I use this material for motor mount for my live steam boats. Yes, this white material is just standard cheap PLA, and this pink material is this. And this is mount for live steam engine with outside temperature about 110-120 degrees of Celsius. And you can see after a few rides of this boat, this part is absolutely without any signs of deformation by high temperature. And these parts I anneal in oven continuously, how I says in previous time. 20-25 minutes, 70, next time 80-85, next time 100, and you can try 102, and you will have, in finish, you will have this 140 degrees of Celsius temperature resistance. What is important? Important is shape of your part. These parts are with I don't know, 4 or 5 perimeters and maybe 80% of infill. This is almost solid part, and these almost solid parts are almost without any deformation during annealing and during cooling after annealing. Yes, but 1 perimeter parts or some I don't know, maybe you know airplanes, RC airplanes by ferdialabprint.com, 1 perimeter and very complex internal structure. These parts will not works with this procedure. Yes, just if you have much air inside your parts and really thin walls for 1 perimeter, etc., you will probably have big deformations and big stretching of parts during annealing and after annealing. after cooling of parts. But this solid parts, almost solid parts, stretch of this part was only about half percent of final size, so it was without any problems. This part, one with money letters on them, on it, is without annealing process, for comparing with this part, which is with annealing process. Yes, without annealing, with annealing, and we will see if will be some different here. Next material is my favorite for most applications, HD-PLA by Pro 3D company. This is print for 3D print, almost and absolutely same like normal nice PLA. All temperatures, hot bed, hot end, everything is just same like normal PLA. But after print, without any annealing, just how is it? You will have temperature resistance about 100 degrees of Celsius. Yes. Standard PLA 50 or 60, HD-PLA 100 degrees of Celsius. Price is about one time or 100% plus normal PLA or 50% plus normal PLA. Price depends on price of your normal PLA. Yes, HD-PLA by Pro 3D, really nice material. Unfortunately, only in a few colors. Here in Czech Republic, only white and black. Perfect material. And number one, about temperature resistance without any special procedure like annealing, and without a special price, without a special print procedure, is Z-UltraT, again by Pro 3D company. Same company which make HD-PLA, same company make Z-UltraT filament. Print procedure is similar like ABS or ASA. It means hot end temperature 220 to 240 degrees of Celsius, hot bed about 100 to 120. Price is higher, maybe 3 times than normal PLA, but after print, without any next procedure, you will have 130 degrees of Celsius temperature resistance. And again, print procedure is very similar to ABS or ASA, but without a smell of normal ABS, and without problems when you will print big parts. You probably know big parts, printing of big parts from ABS could be a big problem. This material is not so perfect about big parts printing, about stretching like normal PLA or HD-PLA. This is not so good, but almost yes, and it is much better than normal ABS and ASA, because normal ABS and ASA are with a similar temperature resistance, almost same temperature resistance, but with problems with stretching of parts if these parts are big. This is almost like PLA. Yes, I had some print issues with finding a right hot end temperature. Maybe you will see that on a video. Here is temperature 245, it was too high. Here is 230 and here 220 degrees of Celsius, it was okay. I have some issues here, but for this test with boiling water it will be okay. So, this part I will test now. One important thing about temperature resistance. If you are near to edge temperature, don't expect same strength like on cold material. If you have over 100 degrees of Celsius with this temperature here under 100% Celsius, okay, it is much better than normal PLA, but you can feel that this material in high temperature usage is a little bit softer, more flexible, and you just must count with that. Yes. So this is next reason for more solid parts, because if your parts is more solid, it will be more strength than only one perimeter part. Sorry for my English, is not easy for me, but I hope I'll tell you now everything about this material. And now I will just put boiling water. We will start with normal PLA, then we will start with this special HD-PLA, but without annealing. It means result probably will be same like normal PLA. After that we will try HD-PLA after annealing process. After that I will try HPLA, 100 degrees of Celsius, and water will be about 95 degrees of Celsius. It will be near to near to description of this material. And last material which will try will be Z-UTRAT by Pro3D. Okay, let's go. Oops. So you saw how normal PLA was gone. Now I will try HD-PLA but without annealing process. So result will be probably same bad like normal PLA. Now we will try HD-PLA again, HD-PLA, but part with annealing process or after annealing process. So result could be much better than previous case. So now I will try H-PLA. This material is only with, is with 100 degrees Celsius temperature resistance without any annealing or something next procedure. Actually, I think it will be close total destruction like normal PLA, because one perimeter object without any internal structure in the wall for better strength, I think it could finish could be really similar like normal PLA. We will see, maybe not. And as last sample, I will torture Z-ULTRAT material 130 degrees of Celsius without any annealing, etc. I expect similar result like HD-PLA with annealing process. It means okay, it will hold the shape, but probably material will be with hot water more flexible and a little bit soft. We will see. I saw some result. Standard PLA just is standard PLA. Temperature resistance of boiling water is really bad. We know that, we expect that, no surprise. Okay, sorry PLA for this torture. HD-PLA without annealing process is just normal PLA. Yes, so don't expect better temperature resistance of HD-PLA without annealing process. You need annealing process for better resistance of high temperature. So I think it's clear. About heat resistance or temperature resistance, mean on that if you will make annealing process, if you will put higher temperature than 80 degrees of Celsius, your part will be something like that. You just really must have exact temperature 80 degrees of Celsius during annealing process, or you will have in your oven something like that. Yes, 80 degrees of Celsius plus minus, I don't know, 3-5 degrees of Celsius. Number 3, bronze medal. Bronze medal. HD-PLA with annealing process. Why number 3? Why not better place? Because this material, manufacturer says this is 140 temperature resistance, but you can see how soft it was. Okay, shape is same like was, shape of this can is same like was, but on top side you can see this is deformed and it was really soft. And if you think on a really difficult procedure of annealing process of you must mean about your parts, it will be okay for the annealing process. What about stretch of parts, etc, etc, etc? Okay, it is fine, but for this problems about annealing process, etc, stretching of parts, etc, I expect a better result. Yes, because really 100 degrees of Celsius and it was really soft, but much better than standard PLA, much better than standard PLA, and much better than HD-PLA without annealing process. So bronze medal, number 3. Number 2, silver medal, HPLA. Why this is silver? Because you can see here some deformations. Yes, I see these deformations too, but this is only 100 degrees of Celsius resistance, and I think it is good job for this material, because this material is really nice to print without any problems. Really, this is really nice for print, for 3D print, and you can use it directly after print without any annealing process, etc, etc, and you have 100 degrees. Okay, maybe maybe not 100, maybe 80, 85. Yes, again depends of thickness of walls, number of perimeters on infill, etc, but really good job. Yes, I like this material very much and I will use it because this is PLA. Yes, this is PLA. You can easily glue it with quinoacrylate glue, etc, etc, but with much better temperature resistance like standard PLA. And number 1 and gold medal is not Ledecka, but this is Z-UltraT material by Pro3D. This is just absolute winner. Of course, I not use 130 degrees of Celsius temperature for this test, but you saw boiling water actually was without any effect on shape, on hardness. Okay, it was a little bit softer and a little bit more flexible, but much better than any other material from this test. Yes, and again you can use it without any annealing process and next complications.
Yes. Again, this is not so good for large parts print like a normal PLA, but much better than ABS or ASA. Yes. This is my favorite, this is my gold medalist, this is my #1, and I like this material. I will make next test about glue for this material, if it will be better with quinoacrylate glue like normal PLA, or if better will be with some acetone glue like for ABS. I don't know now, I will try it. But again, this is my favorite. This is my favorite for really strong parts, for example around my live steam engines. Yes, this will be perfect material for both for hull or fuselage hull of my steamboats. Yes, and this, okay, I have about 1 kilogram of this material. Okay, I will use it, but after that I will not use it again. I will not buy it again. Yes, this is okay, but with annealing process, etc., this is so difficult in compare with these two second materials. So, thank you for watching. Have a nice day. I hope it could be helpful for someone. See you later.